Hey guys, this is just a simple overview of math. Again, nothing special, just kind of what we already went over in class, but something to review in case you have a brain fart or whatnot. All right, so remember King Henry died by drinking chocolate milk with your kilo, your base, and your milli. All right, so here's that. Here's your K's for kilo. Your B is for your base, and millis for millimeters or milliliters or whatever. Your base would be the meters, liters, grams, and kilo is obviously your biggest placeholder there, and milli be your smallest. I didn't put everything else because normally that's not really. So the question would be, can you take 40 millimeters and change it to kilometers? All right, or if you say it like a little kid, kilometers. So what you do is, you may already know it, but to go from here at milli to the base, you've got to go 3 times. So 1, 2, 3. And from the base to kilo is 1, 2, 3. So basically you got to go 6 spaces. So if we're decimal places beside the 0, which we know that, we go 1, 2, 3, 4, 5, 6. Alright. Basically it will look something like that. Alright, so you can count again. I write really messy, so again 1, 2, 3, 4, 5, and 6 will be right here. Alright, so that would be to go from kilometers or millimeters to kilometers, you would go from 40 millimeters, and the same number would be 0.00040 kilometers. Alright, so that would be your answer in kilometers. Alright, the other way to write it would obviously be 4.0 times 10. And again, you went from here now because you moved the decimal place 1, so it would be 5. 1, 2, 3, 4, 5 to the negative 5 because you're moving backwards. It's a small number, kilometers. Alright, so basically, if you can't memorize how far away each one is, just go ahead and draw your KHD, VDCM to memorize it so you can count your decimal places. Remember, when you move from a little placeholder to the big ones, it's going to be a negative exponent. Alright? And when you move from your big ones to your little ones, it's going to be a positive exponent. Alright? So, again, sorry you can't read my writing. Tell that to the Roland Salisbury School Board for not letting me buy a tablet or anything legitimate here. So, alright, moving on to multiplying with decimals. Alright, we can look at this one first. Something real simple, 2.5 times 2.5. Alright, you get your, sorry guys, trying to find my eraser here because I did it beforehand. So 5 times 5 is 25. Alright, apparently I didn't write it. So 5 times 5 again is 25. Hopefully you can read this. So you carry your 2. 5 times 2 is 10 plus 2 is 12. Alright, next one you put your little 0 placeholder. 2 times 5 again is, we'll mark this out now, is 10. Carry your 1. 2 times 2 is 4 plus 5 is, plus 1 is 5, sorry. Alright, so you get 6, 2, 5. Alright, then you count every number that's behind the decimal, so that would be 1, 2. There's 2 numbers behind the decimals, so you put 1, 2. You put a little decimal there, so that's your answer, 6.25. Alright, same thing with this one. Could have put it the other way, so I had to put so many placeholders, but I didn't. So that would be this problem up here. Alright, automatically, if you did it like this, you would know that it would be a number point something because you got 4 minus 3, which means you're only going to have one decimal place past the number. But let's say that doesn't make sense to you. We'll show it again this way. So 5 times 0 is 0. 5 times 2 is 10. Alright, placeholder. 7 times 0 is 0. 7 times 2 is 14. Alright, and then 0, 0 placeholder. 3 times 0 is 0. And 3 times 2 is 6. Alright, so then you get your 0, 0, 5, 7. I think I did that right. So You count your numbers 1, 2, 3, 1, 2, 3, you get 7.5 as that answer. Alright, so again, it's pretty simple as long as you can do multiplications and then you just add up the decimal places. Yeah, so hopefully you understand that now. Alright, and last but not least is dividing with decimals, so division with decimals. And again, I'm picking easy numbers that I'm not going to mess up on while I'm doing this example, but you know, if you understand the concept, it should work for any type of numbers. In the test, again, they're not going to use really hard numbers. Alright, so this is how many times 4 will go into 350. Alright, if I think to myself, how many times something will go into 35, I know that 8 goes into 4, 8 times 4 is 32, so I know it's going to be 80 something. So just out of the top of my head, I could guess 85, just because that's a good number. Alright, so 5 times 4 is 20. 4 times 8 is 32, 35, 36. So, is that right? That would be 34. So we're about 10 off, so I'll just go up a couple. So 87 times 4. 7 times 4 is 28. Carry your 2. 8 times 4 is 32. 33. God, I can't even count. 8 times 4 is 32. So it's 33, 34. So you get 348. Alright, you guys laughing at me now, but it's really awkward talking into a computer. Alright, so this is going to be 8, 87. 87 times 4 is 348. Alright, which gives us, you probably don't have to do this, but just in case, that's going to give us 2 left, which is where you bring down that imaginary 0 to get the rest, and that's how you know the decimal goes right there. So when you run out of numbers to deal with, that's when you put your decimal. Alright, something times 4 is 20. Well, 5 times 4 is 20, so there is our answer. Alright, and that's just that simple. So just remember that with simple division that you have to obviously know your multiplication, which apparently I'm having a hard time with, but you gotta know that. And then whenever you run out of your numbers that you're dividing with, that's where you put your decimal. And again, to change this to scientific notation, it would be 8.75 basically times 10. Times 10 to the 1 power. Alright? Alright guys, hope that helps. If it doesn't, I'll try it again. Just let me know.